Hello everyone and welcome back to my another tutorial. This time it will be a little different. In several previous tutorials I was showing you how basic stuff with TensorFlow, and right now I decided to move on with PyTorch, and right now I will be shifting my machine learning training utilities with this PyTorch. So it means that I'm gonna detach TensorFlow from machine learning training utilities, and I will make it to work with both TensorFlow and PyTorch. But before that, I'm making this kind of PyTorch introduction tutorial to understand from basics how it works, because there will be a lot of refactoring we'll be doing, and I'll need to make some kind of wrapper to make it work like functions, blocks, and similar like a TensorFlow. Because right now when we are working with a PyTorch, we need to write everything from zero by ourselves, and this sometimes consumes a lot of time. But before doing all of this, I decided to make this PyTorch introduction tutorial where I'll show you how we can simply classify MNIST digits with convolutional neural networks very simply, and we can train this on our CPU, I don't know, in 5 minutes, and we have a working classifier. So let's do it. But first, let's see how, for example, our structure of training models would look in TensorFlow. But if you are not familiar with TensorFlow, don't worry. It's only a few minutes to show you how it works with TensorFlow, and then we'll go to the PyTorch. So basically, in TensorFlow, what we are doing here, I have a handwritten recognition tutorial with TensorFlow, and I'm importing a lot of stuff. But basically here we are pre-processing the datasets and etc., preparing it to work with a training loop. And here is data provider. We'll talk about this later. But basically, here's the augmentation techniques. And here, for example, we are defining our TensorFlow model. And this is kind of, I'm importing it from another file. And if we go here, I have a specific structure where I apply the inputs, and here I construct the model at the end of it. But let's go back. And then we need to compile it by giving it an optimizer, loss function, and metrics we want to track. For example, here we're tracking C character word error rates, and I made this as metric. But if we continue, here we have a lot of metrics that help us to stop the training when we want, save it on disk, save the logs, save it on TensorFlow, reduce learning rate when necessary, and of course we convert the model at OpenCV when our training finishes. And this stuff then PyTorch doesn't have. And here simply we call the model fit function to fit the model. This means train the model, and exactly the goal is similar in PyTorch. So let's go back to the PyTorch, and we will run line by line here. So for my tutorial, I'll use the MNIST images. But first, before doing all of this, we need to import the torch. So basically for this tutorial, you can you can install CPU torch. You don't need to worry about GPU as of yet, because, well, it's pretty small tutorial. And then we are creating this network. Well, we importing it, not creating. We'll come back to this a little later. And here is pretty specific code that downloads an MNIST datasets from this kind of link. This is a training target, validation and validation target batches. And each batch, for example, training batch consists of 60,000 training images, and validation consists of 10,000 images. If we go further, you can see it here. So for example, the best way to do this is to run the debugger mode, and we can check everything out. So I go to here, I run this file as a debug mode, and we'll go step by step and we'll see what we do here. So we have a training data here, and as you can see, as I said, we have 60,000 images, and each image is by 28 by 28. So we will show a few images here, and we'll stop on the next step. So let's run this, and it should show me here's the 5, and if I move on, oh, I quit. So don't worry, everything is still fine. We can restart because it quit because I pressed a Q button that is not necessary. So here is 5, here's 0, 4, 1, 9, 2, 1, 3, 1, and etc. There is 60,000 such images. As you can understand, it should be pretty easy to recognize these for our neural networks. And these images are 26 by 26. I simply resized them so they could be shown here. Okay, it breaks here. So let's move on. So here I will train the model for 5 epochs, and I will use the batches of 64 for training and 64 for validation. And basically we'll use 0.001 learning rate. It's pretty small. And here what we use a NumPy to resize our data. So this means right now it's 60,000 by 26, and if I type shape, it gives it. And right now we will normalize our images to be between 0 and 1, because this way our neural network is way easier to learn what it can see. Also, we could normalize it between -1 and 1, but it's a good practice if you are a starter to run it, to normalize it between 0 and 1, because there is some kind of inside details when we need to do so. So let's move on. And of course we're gonna expand the dimensions, and this is because we will feed this kind of images to convolutional neural networks, convolutional layer. It needs to be a little bigger. So for example, if we have an RGB image, it has three layers, so it would be 28 by 28 by 3. But right now, because it's only one channel, it's grayscale, it doesn't have it. So we can't use the convolutional neural networks. So in this case, we need to expand the dimensions. So here we simply will add additional 1 dimension. And if I press next, I press the same shape, and you can see there's 1 here. So right now it will work with our network. So let's move on. We do the same with test data, and here is train batches. And the idea here that we want to create these batches. For example, when we are giving for neural network training data, it works way faster. For example, when we are giving it 10 images at once. So in this case, we have 64. So this means we'll give us 64 images at once for it. So I'll show you in a moment. So I click next, and it created these batches for me. And if I will write a length of these, you can see that right now we have 938 batches. And of course, we can print a shape of one batch. So I press a shape. No, it's a list, so it doesn't work like that. So right now you can see it's not 60,000, but 64,000. And I mean 64 elements in this batch, because 60,000, it might not fit on our GPU to train, and it may be really hard for our networks. It might be too big, but it still might work. It depends on what GPU you have. So that's basically what we do with these train target batches, that we gonna iterate. And we do the same with our target. And it's here train batches. I mean here train target batches. And we can also print the shape of it. It should be 64 by oh shit, sorry, by nothing. Yeah, that's exactly, that simply tells what's the number is of that, in that kind of, what's the label is in our first image. So for example, we can print what is the label of our first image, what will be the label of our second image, third image, and so on. This is the true value for our kind of images, MNIST images. And right now, as you can see, we came here and we want to test what is this. So we need to construct a neural network. It's pretty familiar like we do in a TensorFlow, but in TensorFlow, we are constructing a whole network and we are compiling it. Here, for example, if we would like to check what's the structure of our network, we will need to run one inference through our network. So let's go inside and you look. So here, basically, we are defining the layers that we're going to use in our networks, and then we will simply apply these layers in an order we want it to be. So for example, I define it like these, and for example, here is the input for our network. So for example, batches count. And here is the, for example, this is the output shape that will come from previous layer. So basically, you'll see in, shortly what I mean here. You don't need to worry right now about this, because usually if you are a beginner, you're mostly gonna use already written networks from somewhere you Google. It takes time to learn writing these constructions of architectures and so on, to use step by step what goes after what. So this simply takes time, so don't worry right now. We move on. So let's move out of this function. Network gonna be defined here. And right now, this is a pretty specific function. In TensorFlow, there's a specific function summary that we applied on our model. And this gives us an architecture of our model. And TensorFlow don't have this kind of specific function, but there's another library, Torch summary. If you're going to install it, you might see that it will print us this kind of summary of our network. And if we go to terminal, you might see that here's our network. So this is kind of differently what we saw on the code. It also takes time to get familiar with, but simply we don't see the input layer, but there was this is the batch count, and there was 1, there was 28, and here is 28. So basically this applied one convolution layer that output was 10 by 24 by 24, and well, etc. It moves on, then 20, 8, 8, and etc. And the last layer is the linear, and here is the batch count, and this is the 10 possible predictions, because our MNIST has 10 different digits from 0 to 9, that's 10, and that's exactly what we are trying to predict. So cool, move on, and we'll apply, we need to define the optimizer. So here is pretty similar to TensorFlow. We import the Adam optimizer, and here we need, differently from TensorFlow, we need to apply these kind of network parameters stuff for this optimizer, and this is well, this is necessary. When we are starting with TensorFlow, we don't need to worry about this stuff. Later, after several months, when we are writing our own custom functions, this might be necessary, but who cares right now? And here in Optimizer, we define our learning rate. That's cool. And then we define our loss function, and this is specific cross entropy loss for classification stuff. And also, you don't need to worry right now. And let's move on. So I can minimize this. So right now I defined 2 loops, because, for example, when we are training network, we need 2 loops. One is for training and one is for validation. That's why we have 2 different data sets that look very similar, but that they are not the same. They don't have identical images, but because this is very huge data set, of very small similar images, there might be very similar images either. So how our training loop looks like. So first, what we need to do is we need to define, to push our network into training mode. And then we need to, well, be summing loss over all the iterations, over all batches. So here we simply creating a TQDM. This is a bar. So you'll see that it looks way more fancy when we see a moving bar instead of running numbers in a terminal, so we can see the progress of our training. If you are here with Python for a while, you should be already familiar with it, so it shouldn't be something new for you. So then we apply a zip function. So this, for example, what this does is it takes one batch from training batches and one batch from trained target batches, and these two batches it gives to a network, because with a training batches, with these images, it tries to predict on them. And then when we have our predictions, we need to compare these predictions with our target predictions, and we calculate the difference between predicted label and true label. And larger the difference is, the larger the losses that we need to minimize. So that's pretty simple. So then we start here from 1. I increase this because we'll use this index later. So on the PyTorch, when we are training it, all the data should be in a torch type. But here our data comes in a NumPy. So what we do here, we simply convert them to PyTorch, and that's nothing specific here. And of course we need to apply that it's float, and here is a long data. So then we need to apply 0 grad to optimize it, and then we do a forward step through our network with our data. Then we, as I said, we calculate the loss when we have our predictions and targets. We calculate the difference, and then we are stepping the backwards function to minimize the difference on the next step. And we do this over and over. And then we apply simply a step optimizer step function. That's nothing magical. So here, because we have a for loop here, we need to save our loss value, because we could see how it changes. Usually it should be decreasing. So here I'm increasing this sum, and simply for this description bar, where it will be progress bar, it's called. I'm updating the description to see what epoch we are and what loss we have at this, for example, epoch or the specific step. Every step I'm updating this, because we are summing all the losses. We need to divide it by index to know what is the loss actually. And then we do very similar stuff with our test batches. So we will be collecting the correct predictions and loss, of course, to track it up. And then we are the same way we are creating a progress bar, but right now here we need to use with torch no grad. This means we are not training it, and we need to specify this with network evaluation mode and not to have a gradients. So here we're simply doing our predictions, and that's it, nothing else. And yeah, we calculating the loss, and we checking what are the actual predictions, and we calculating the accuracy here. And this is kind of specific function for that accuracy, and well, nothing magical either here. And then I'm updating this description progress bar to know what is the validation accuracy. And then, well, when we have these training and validation functions, we can create this kind of loop. We need, for example, right now I will be training for 5 epochs. Yep. And I'm doing so. After these 5 epochs, it will break the loop, and it will save the model for me. And as you can see, I here define the path where I would like to save it. And this 2 lines creates the folder. It doesn't exist in my file structure, and then we simply call the torch save function, and we get the state dictionary from our network and simply save it to model.pt format. That's the specific format for PyTorch. So basically nothing magical here. I can run this loop. I continue debug mode, and it should, yeah, as you can see, it started to moving on. And as I said, it's right now on CPU. My video recording might be laggy, but I'm not worried about that. So, and you might see how the loss is changing. As you can see, loss is decreasing every step. So we shortly, you can see validation loss is way lower than validation accuracy, and you can see that this is difference. And this tells me that 95% of our predicted images were correctly predicted. And that's all. That's how it trains. And so right now, what is left, we need to wait it to finish the training process, and I'll show you what we can do next. So let's wait shortly. So as you may see, it finished training and we achieved 98% of accuracy. That's pretty nice, but we know that we tried this on simple stuff. So why we are so excited? If we are starting to learn new things with a PyTorch. If you are new in the machine learning, PyTorch, it's a good start to test this everything out. So right now we have a training model. Okay, we saved it to our dictionary and so on. What we need to do next? Here I have another function that is called test.py, and basically here I will open the same dataset, the same code that I used before. I don't load it, but instead right now I load only training, I'm loading only validation data. That's cool. Here is model path where I save this. And differently from TensorFlow, in TensorFlow we were able to save a model on disk with a full architecture. In PyTorch it's different. We need to know our architecture, we need to construct this model, and then we need to load the weights for our model. And we do this with a load state dictionary from this kind of file. And then when we are doing the predictions, we need to turn on evaluation mode for our model. Great, so the same as before, I'm just simply looping our data. And as you can see, here is my test image and test target. And simply differently from before, as you can see, I applied the reshape for my images here instead of somewhere later. So keep notice that I still need to add additional axes for my data images. And then we need to normalize it, and that's it. And that's, we can test to run this code. So open this, I turn on to run the code. So inference image, let's see what's the shape of my image. As you can see, 28 by 28. Why is it so? So you can see that there's one batch on our inference image. I'm not sure why it was 28 by 28 here. So I think it's not necessary to do this step. So that's cool. And it should work. That might be my mistake. So let's check again. Inference image, what's the shape? Oh, I know, I applied, yeah, I added additional axes here. Yep, that's right. So this is necessary, sorry. And it will not work without this line. And basically we run the predictions and we might see the numbers. Here is prediction is 7. So here I have a image show, and here I type what is the prediction label for my network. Sorry. And let's run this again. I simply pressed the Q button accidentally. That's my mistake. Sorry for that. And here it is, it's 7, and we move 1, 0, 4, again 4, 9, 9, 9, and these are keep changing because I'm not destroying the windows. Yeah, and destroy only there. That's good that I noticed this. This is pretty simple, and you might see how to run this inference. And this is nothing magical. It's 1, 0, 4, 1, 4, 9, 9, 0, 9 again. Well, as you can see, for us, it's pretty 100% accuracy, and that's only because it's pretty simple task. But for learning purposes, it's amazing start for the beginners. And in next tutorial, I will move on with a torch wrapper to make it way more easier to train without writing the train loop and test loop and etc. That will help us to train our models in more basic and automated way. You'll see this will be amazing. And I decided to move on with my machine learning training utilities to work with both TensorFlow and Torch. And in the future, I'm thinking about creating some amazing project with this package. And I believe after a year or two, my package will be used massively and by many people online. So be the first who tries it out. And this is it with this tutorial. I wanted to introduce you with PyTorch, and in the next tutorial we'll break a little harder stuff, and we'll see. This will be pretty amazing. And I hope this tutorial was really useful for you. You can find all the code in the link description below this video, link to my website, text version tutorial, to my GitHub code, and don't hesitate to smash the like button, subscribe to my channel, and we'll see you in a next video tutorial. It's a pleasure to teach you the Python and machine learning stuff. See you in the next video. Bye.